Welcome. We are looking at how to calculate variance and standard deviation. We're going to use this first example here. And I'll start off with the concept that this has to do with a normal distribution of data when if you take the average or the mean, which is shown like that, the standard deviation helps to figure out how to organize the data in a way that makes more sense, usually by splitting it up into groups called distances from the mean or standard deviation. And we use the variance to get the standard deviation. So we're going to start with that. So I'm going to take these numbers here, and the first step to do is to find the mean. So 1, find the mean, which is the average. And we denote it by using x with a line over it. So if we take those numbers, 32 plus 41 plus 35 plus another 35 plus 46 plus 42, and divide that by how many there are, which is 6 of them, we get 231 over 6, which is 38.5. Generally, rounding to one decimal place is the best way to do most statistical numbers, unless you're told different or there's a reasonable reason why not to. Now, the second thing we will do is to calculate this variance. The standard deviation will be very easy because it's nothing more than the absolute value, the square root of the variance. We use this symbol, which is like an O with a little tail at the top of it, and squared. So when we take the square of it, root of it, we'll get the variance. And the way we figure it out is we take the first data point, so I'll take this one, and I do subtract from it the average, 38.5. And you square that. Actually, I'm going to come back here and I'm going to do this algebraically. And so what I want to do is you take the first data point and subtract from it the mean or the average. You add to it the second data point, subtracting the average squared. You add to that the third and the fourth and the fifth, all the way until you get to the last one, and we'll call the last one n. The last data point, subtract the average or the mean, square it, and all of that divided by how many there were. In this case, it was 6, but we'll do n. So this is what's called the algebraic, this is like the algebraic steps to do it. And there are a couple of other ways to show it with summation notation and the square root itself to show the standard deviation. Well, now we're going to do that with this actual numbers. So the standard or the variance is equal to 32 minus 38.5 squared plus 41 minus 38.5 squared plus 35 minus 38.5 squared plus a 35 again minus 38.5 squared plus 46 minus 38.5 squared, and finally 42 minus 38.5 squared. And all of that divided by 6. So if I did each one of them separately, the first one, 32 minus 38.5, do it and square it, and you get 42.25 plus 6.25 for the next one, plus 12.25, and twice because 35 was in there as 2 data points, plus 56.25, plus 12.25, and all of that over 6. You see where this can get pretty tedious. Well, using a calculator or calculator specifically to do this would be helpful. And of course you would do that most of the time, but you will need to do that at least once in directly written out like this if you do it for me. So let's finish out the results of this. This comes to 141.5 over 6, which is equal to 23.6. And that number is the variance. This is actually, I should specifically tell you, this is sigma. That is the Greek letter, the lowercase Greek letter of sigma. And so sigma squared, and that's the variance. The variance. Finish out that 6 so it's more like a 6. We'll just fix that. And you have a chance to catch up here. Now, once we have that, the next thing, the third thing, is to find the standard deviation. Standard deviation, which of course we can just do SD, but it actually is that sigma symbol, not squared. So to find that out, we take the square root of the variance, or the square root of sigma squared, and we just figured out that that's 23.6. And thus we figure out that's approximately 4.9. So what's this mean? Well, now I'm going to make a nicer bell curve here. And right in the center is the mean, which we know is 38.5 here. That's the number 38.5. Well, if we go one standard deviation less than that and one standard deviation greater than that, this amount is what you put. Or you go from 38.5 plus and minus that. So I'm going to add 4.9, and I'm going to subtract 4.9. And that gives me 43.4 and 33.6. And when the data is set up distributed like this, it tells you that between one standard deviation below or above, 68% of all the data is in there, reasonably close to the average or the mean. And in particular, this part is half of that, or 34%, and this part is half of that, 34%. If we were to go out another standard deviation, this full amount is 95%. Oops, I shouldn't put it there. I should put it more, actually, I think I should do it more like this. If this to this, that's a 95%. That in green. 95% is within 2 standard deviations. So in this case, we would do the numbers of 28.7 and 48.3. So from 28.7 to 48.3 is 95% of the data. Now, as far as what the data is, we only had these numbers, but this is representative of perhaps 1,000 numbers. And if you had 1,000 numbers spread out with that, such that you had that average and enough numbers to be the same as that, then this is what the bell curve would look like, and what the numbers would be that are 1 and 2 standard deviations away. That can be used in many applications as a statistical analysis of data to help you then make predictions or explanations or analysis of what the data means. Well, let's review these steps. The first thing was to find the average or the mean. Second was to find the variance, and that's the one that can be a bit tedious to do, so you do it very carefully. And then third was to find the standard deviation, which is an easier thing to do once you have the variance correct. Here is another problem, and I want you to do this for practice. So pause for a moment, work on it. There's only 4 numbers, but think of them as representing, say, 400 numbers or more. But use those 4 to do all these steps. With 4 of them only, there's less steps to do, or there's less work to do for finding the variance. And so there's enough time you could easily do it. So go ahead and do that. Pause the video for a moment or while you work on it, and then come back to it, and I will start explaining it as if you were now coming back to it. All right, our first step will be to find the mean. So for that, we will add up the numbers. Whoops, let's fix this, get it back to where it should be. 50 plus 85 plus 74 plus 80. And if I add them all up and divide by 4, I get 72.25. And so that's the mean. The second step, I will find the variance, which is standard deviation squared. And so I'm going to follow this pattern of the first data piece minus the mean squared, and I will do that every time until I have them all done. So it's 50 minus 72.25. I am going to do that so I can fit it all in one line, which means I'm going to come here and start over here. So it's 50 minus 72.25 squared plus, next number is 85 minus 72.25 squared plus 74 minus 72.25 squared plus 80 minus 72.25 squared. And there are 4 of them, so we'll divide by 4. And so for the continuing it, when I do this one and square it, I get 495. I think I'll come down a little bit more for that. 495, and the next one's 163, and the next one's 3, and the next one's 60 over 4. You'll never get a negative or subtracting there because you're squaring every number, even though you have sometimes a case where you're like this one, you get a negative number, but when you square it, it becomes a positive number. So, and when you do all that, you come to 721 divided by 4, and that results, I'm going to do sigma here. I'm not so very good at drawing, including drawing Greek letters, but I think I can get it reasonably close. Oh, not that one. Let's try again. That looks too much like a 6. So I'm going to do an O and a little tail. And that equals, because of the 4, it goes 2 decimal places and stops. So we'll use that. 180.25. Be a little more precise going more decimal places there. So that would be the variance. So, oops, I forgot to put the square because otherwise it'd be standard deviation. So we have the mean here, and we have the variance here, and now we find the standard deviation. And for the standard deviation, just take the square root. So I'm going to write that to get the standard deviation, take the square root of the variance. So sigma is equal to the square root of sigma squared, which is the square root of 180.25, which is approximately 13.5. And that's the standard deviation. So that means that if we did a bell curve, we would have the center 72.25, or the mean. And then you'd have one standard deviation both ways. So let's calculate that. You don't have to do this to find the standard deviation. I'm just sort of adding it in, that the concept of this is you would have 58.75, and here you'd have 88.75. And I'm just checking my numbers. And this amount to this amount is 68% of the data. And then we could go further, another standard deviation if we wanted to incorporate 95% of the data. But the goal here first was to determine what the variance was and what the standard deviation was, and we've done that. Now you've done that too. You have an example here, and you have an example here. So hopefully you are comfortable now with the process for calculating variance and standard deviation and the basic meaning of it for analyzing data that's in a normal distribution. Thank you for watching and listening, and hopefully it was helpful. Have a good day.